All right, so here we're supposed to find the critical numbers of f, the intervals on which f is increasing and those in which f is decreasing, for f of x equals 1 minus x to the 1/3 power. All right, so let's take the derivative of f of x. All right, so if we take that 1/3 down in front, we get 1/3 times 1 minus x. And now it's going to be what? To the negative 2/3. Now the derivative on the inside is going to be a negative 1. And so now, if I rewrite that, that's going to be a negative 1 over, and then we're going to have what? 3 times, oops, that should be a 1. Well, yeah, well, we need to rewrite that. 1 minus x to the positive 2/3. Okay. All right, so that's rewritten in the form where we can use it the best because now what do we know? Well, we know at this point here x cannot equal what? 1. Why? Because that would make 0 in the denominator. Okay. And so we know that. So what we have to do now is what about f? Well, f up here, we can plug any number up here. So this is going to be what? It's going to be continuous everywhere. Okay. All right. And since it's continuous everywhere, here, this means it can't be here. So what do we have? Well, let's look at our values here. So if this is 1, let's look here maybe at, I don't know, we could do 0 and we could do 2. Okay, well, if we plug in 0, that's going to be 1 to the 2/3. That's going to be 1 and times 3. So that looks like it's going to be a negative number. So these over here are going to be negative. What about 2? Well, 1 minus 2 is going to be positive after you square it. But then we have a negative up here. So it's going to be a negative here as well. Okay. And so while we have this open spot here because we can't have x equal 1 because we get a 0 in the denominator, we have the same thing here. It's decreasing, and here it's decreasing. And so since it's decreasing over the whole interval, that means that this has to be our critical number. Or yeah, number. Okay. All right, so that's because this can decrease on the whole interval. It's not just stopping and then making another decrease again. It's decreasing on the whole interval. And so then our critical number is x is equal to 1. Okay. All right, let's do another one. So it says find the critical numbers of f, the interval in which f is increasing, and those on which f is decreasing for f of x equals 1 over x. Well, let's rewrite this because we know it's easier to have values as, exponents. And so now we can find f prime of x easily, that derivative. So it's going to be a minus 1, x to the minus 2, or a minus 1 over x squared. Well, what do we know about here? Well, here, x cannot equal 0 because if we do, we have 0 in the denominator. Okay. All right. So now what do we have? Well, let's look at our sign chart here. And here's 0. Now is 1 over x continuous? Well, not really, because we can't have a 0 here. And so because we can't have 0 here, it's not continuous at that. And so probably the best way to look at this would be is to graph that. And I guess we can put 1 divided by x. And what do we get? Let's see. We need to get our right window maybe. And so we can see we're coming in here, we go down here, we don't hit 0, then we're coming here and we go down here. So we're that x is equal to 0, that is going to be a vertical asymptote there. And so that means it's not continuous at this point. So here, this one we know is not continuous at x is equal to 0. So now let's see what we get here. If we put in a negative 1 or a positive 1. Well, if we put in a negative 1 or a positive 1, what are we going to get? Well, we're going to get a negative 1 out. And so it's going to be a negative throughout there. Okay. So what we have to say then is at that point, f is not continuous at x equals 0, so it's not a critical number. So because it's not continuous here, we can't have it equal to 0 here. Then that says then that x equals 0 is not a critical number. Okay. Now, if this had been continuous here and it would look like that, then yeah, then we would say that would be a continuous number and it would be a critical number. But because it's not continuous up here and we can't be equal to 0 here, then all we can say is it's decreasing from negative infinity to 0 and from 0 to positive infinity. So that's kind of where it's decreasing. Whereas the others where they were, when we had a critical number, they were decreasing over the whole negative infinity to positive infinity range. So it was over the whole range where this one's not. Okay. All right, so let's stop there and we'll come back for more.